Hello and welcome to this class on constraint and unconstrained optimization. So this is a TS session and it's an additional thing. So it will be just in 1 hour summary of whatever you have learned in this course. Okay, so I'll just write down a few things. Yeah. All right. So hope my screen is visible and let me check if I'm recording or not. Yeah. So this is being recorded. So let's start. Let me start with some of the topics. So this will be just a summary class of whatever you have learned in this course. So this course, as you know, the name of the course is Constrained and Unconstrained Optimization. But you can think of it as divided into two parts. One is the obviously the constraint optimization, and another is unconstrained optimization. Now, in addition to that, there can be another classification. The way this course was structured. So let me write it this rating. So one is linear optimization, or you can think of it as or call it as linear programming. And the other is nonlinear optimization. So the first part was taught by Sir, and the second part was taught by Ma'am. So the things that you have learned. So first, you learned various techniques of, say, linear programming problems and how to solve them and so on. So let me just give a quick week by week kind of an overview. So I'll just open up the assignments of every week and give you the overview. So I'll just check. Wait for a moment. Mm, So just a minute. Okay, so where do I have this assignments? Yeah, finally got it. Okay, so in week one that I'm noticing, suppose week 1 to 6. So this is the discussions was on linear programming. Week one, let's quickly do a summary of what the things that we did. So one thing is that how to formulate an LP. So LP formulation. Given a problem statement, you can formulate it. And then what you had is so it's similar type of problems. Uh, so then solving an LP using graphical method. Okay. So you had some questions related to that, and after that, I think the discussion was on basic solutions. And then there was a discussion of basic feasible solutions or BFS, whatever they call it. And then you had this basic variable, non-basic variables. So these are the concepts that you learned in week one of this course. So let me take an example. So, so I'll solve one of the assignment problems just to refresh your memory. So just one illustration. One would be find the basic feasible solutions of the following system of equation. One would be this. Just write it down as x2 plus x3. So in order to solve it, what you can do, so just quickly check. Yeah, so one way of, I think I solved it in a different way, but what you can do is you can, so x3 is common in both the equations, so you can have like x3 as 0, and then you have x1 as 1, x2 as 4. So 1, 4, 0 could be one solution, right? Then probably what you can do, you can set x1 as 0. So that gives you x3 as half. And once you have x3, then you have x2, right? So that's 7 by. So that's another one, 0. So these are all basic feasible solution. 7 by 2 and half. Now suppose we set x2 as 0. Then what do you have? x3 as 4, but x1 is less than 0, so this is not possible. So the basic feasible, so these two are BFS here, right? So these are the kind of concepts that you learned in week one. So let me now move on to week two content. Okay, so this is week two, and let me open up this assignment again. Yeah, quickly check. Okay, in week two, what you learned is that you learned bigger method. Then you also, I think, learned about simplex method as well. Then I think you had uh, concepts of uniqueness, unique or unique solutions. You had the concept of reduced cost, that check J minus Cj thing. Then mostly it was began method that I could notice. Yeah. So these problems were a bit dense, and you have had to do a lot of calculations for keeping those tableau things. So I'm not going to solve it now because that was already discussed in the week two assignment while I solved that. So that's fine, I think. So now let me move to the third assignment and check what was the content in there. So I think in your exams also you might find similar things, right? So it's better to have a good refresher and then prepare for the exam. So week three, so it's you had this concepts of two-phase method, right? Two-phase method. Then there were questions on two-phase simplex method and two-phase method. So that's mostly that. Then you had degeneracy. Then this you had this concept of departing and incoming variable or departing vector, for ties and so on. Then you had, I think, solving LPs by simplex method. Okay, so these are the main things that you had. So let me check if I can solve one of the problems, or is it? I think they are also too fast. So these problems are too dense because uh, you have to do those tableau thing, right? Okay, so let me quickly check. Yeah, which one is relevant? I think so. Few things to I think remember. So when I using this one or this one, this one. Yeah, when there is a tie in selecting the departing vector, the next solution is bound to be degenerate. Okay, and there is another concept that I'll write it down. Just a minute and just check. Yeah, so you can have it as degeneracy. occurs when some of the basic variables have zero values. Okay, so that's all about this week 3 content. I'll move on to the week 4 thing. This is say week 4. So in week 4, I'll open up the assignment and check what are the things that was there. Okay, so in week 4, you learned about the sensitivity analysis. Okay, and then so it's both in terms of changing in the or change in the cost coefficient, change in the RHS vector. Okay, then what you learned is that yeah, primal and dual problems. Then converting primal to dual, vice versa. Okay, solving the primal and dual problems. A bit of duality theory, and bit of dual simplex for that, right? Okay, so the main thing, some of the main thing that you can remember, so probably just write it down. So any feasible solution to the dual problem provides a bound on the objective of the original primal. Then what you had is some of the things that were there in the assignment. I'll write it down, but just a minute, I'll check if I'm recording it correctly. Yeah. Okay, so the next one is, let me write it down. So if any variable of the primal problem is unrestricted in sign, then the corresponding constraint of the dual is an just a minute, is an equality, right? Yeah. And uh, you can have it another way. So if any constraint of the primal problem is an equality, then the corresponding variable of the dual is unrestricted in sign. Okay, so these are the things to remember. And yeah, the other things, yeah, for dual simplex method, initial simplex table should produce optimal and infeasible solution. Yeah, so we don't care about feasibility, right? And in dual simplex table, the variable which departs the basis is identified before the entire variable. Okay, so now let me get into week 5 content. Week 5, you learned about again dual simplex method. Then there were many questions on dual simplex method itself. Yeah, then I think uh, there was discussion on mixed integer programs. Fixed integers linear programming, MILP. So in this context, there was discussion on Gomori's cutting plane method. Then there were discussions on branch and bound method. And then there were discussions. So these are the main discussions in that week. And so what you so what I can do, I'll just solve one problem using branch and bound method. So, but I think that's bit, yeah, bit involved. So let me not solve it, but probably what I can do. So the NP method. Now you have this as an integer variable. So what you do typically in branch and bound method, suppose this is your root node, and then you fix variables. So suppose you have x1 belongs to say 0, 1. So what you will do, you will probably take the left branch, which is solving for this, and the right branch solving for this, right? So you are kind of fixing of variables. Fixing of variables, and you traverse this tree, right? So now you got at another node here, this node, and probably another this node. And then probably we'll do the same exercise with say x2 less than or equals 0, x2 greater than or equals 1, and you have to traverse this branch boundary to get to the entire solution, right? Okay, so let's not get into the details of it right now. So I'll just quickly get into the week 6 assignment. So in week 6, 6 contains first is, I think, there are discussions on transportation problem. Yeah, so I think the calculations were a bit involved in this what do you call it, this assignment. Then there are different methods of solving it, and I had solved it in the class. So row minimum method is one. Then you had problems on column minimum method. Then you had something about northwest corner method. And then you had matrix minimum method. Right. And then uh, you had this FAM method, or Vogel's approximation method. You also had UV method. So these are mainly for generating feasible solutions. Or this one, this two could be for optimal solutions. Or UV method is the one I think for the optimal solution. Okay, next you had some discussion on job scheduling problem. So it's this kind of special type of transportation problem. Okay, so yeah, I'm not going into the details of it. So that was the main discussion on the linear programming part. So I'll start with this week 7 thing. So I think I have some half an hour left, and let me just quickly check recording. Yeah, still I have half an hour, but I had some 10-15 minutes of content to discuss anyway, so just come back after 2-3 minutes. Okay, so let me discuss so this week 7 content. So actually, let me write it down this way. Week 7 to week 12. So there were discussions on nonlinear optimization. All right, so uh, let me go this one by one. So week 7, what you had is that so you were uh, getting familiar with, I think, polynomial, posinomial, those kind of terms. Then quadratic functions. So that was like these kind of expressions with capital Q being a symmetric matrix. Then unconstrained optimization of single variable. Single variable. Okay, so finding maxima minima. So finding local or global maxima and minima. Okay, so point of inflections. Then what you had is uh, graphical solution, similar to what you had in LPs. Okay. Stationary points and saddle points. something happened with this. Sorry about that. Screen went off for some reason. But the rest of the thing should be saved. Yes. Yeah. So it is saved. Okay. Stationary point and saddle points. So yeah, that's all about this week 7 content. And the main thing to remember was that if prime x equals 0 or grad of fx equals 0, those kind of things, then are if double prime is greater than or equal or less than 0, or getting the Hessian matrix and checking for positive definiteness or positive semi-definiteness. Then you have negative definite or negative semi-definite, right? So these are the things to check for, right? So this is Hessian matrix. Okay, so let me get into the week 8 content. Okay, so in week 8, what you had was first the discussion on unimodal functions. Okay, so next you had different methods like interval halving method. Then you had this exhaustive search method, and these are mainly for this unimodal functions. Then you had also this dichotomous search method. Okay, and then you learned about, I think, Fibonacci method. Finally, you learned about this golden section search method or golden section method. Then you learned about this quadratic approximations. Okay, so let me just briefly talk about this golden section method. So here, what you have, suppose I give you this x1 and x2 belonging to A and B, and overall length of the interval is L2. So, sorry, L0, you get x1 as A plus this L0 by gamma square, x2 equals B minus L0 by gamma square. So the value of gamma value of gamma, which is 1.618, and also sometimes it's called as the Golden ratio. So that's something to be mindful of. Then something about different accuracy levels and how many kind of function evaluations we need to make, number of function evaluations. Okay, so that's all about it in week 8 content. So now I'll move on to this week 9 content. Okay, week 9, I'll open up this thing. Okay, so in week 9, what you have is steepest descent method. And directions. Then you have optimum step lengths. So next you have, I think, solving nonlinear optimization problem, and this is constraint optimization now. By method of substitution. Then Lagrange's multiplier method. So that's one of the main topics of this course, right? So these are again for quality constraints mainly to begin with. The other thing could be for equality plus inequality constraints. Okay, so in this, and method of substitution is like, so this is now for constraint nonlinear optimization. Okay, so that was all about week 9. We check how much time I have. Okay, I have around 15 minutes to quickly wrap up these things. So week 10. Yeah, open week 10's content. Just a minute. Okay. So in week 10, what you have is this directions. So one is the feasible direction, and the other would be descent or ascent directions. Then you had, I think, similar problems only. Then properties of the Lagrange multiplier. Multiplier, and then you had KKT conditions. This is like constrained optimization on nonlinear. Optimization problem with both equality and inequality constraints. Next is, I think that was the solving this solving problems using KKT conditions, right? So these were the main topics of discussion in week 10. And I think there is something important here. I'll just quickly write it down. So I think related to the feasible direction. So suppose I give you this min of fx subjected to gi of x less than equals 0, x greater than equals 0. Then suppose gix is an active constraint. Then you have sorry, it should be less than equals 0 for a feasible direction, right? Next, what you have is that S transpose delta F less than 0. That means S is a descent direction. Yeah, those are the couple of things to keep in mind. Then let me get into this week 11 content. Okay, so yeah, so here what you learned is first is Kelly's cutting plane method. Then you learned the term called usable direction, so which is both feasible and say descent or ascent. And in this context, you learned Zutendeit's method. Okay. Then there were discussions on exterior penalty method. Then, so is the penalty term or penalty parameter, so both properties of that. Then solving optimization problems using steady penalty method. Okay, so that was all about this week 11 thing. I'm not going into the details of it. So let me quickly wrap up with week 12 thing and check. Let me check how much time I have. Okay, I have some 7 minutes. Okay, I'll be back in 2 minutes and wrap up this thing in the next 5 minutes. Okay, so let me quickly wrap it up in the next 5 minutes. So anyway, I have posted the week 12 video just now, and I'll post it this one as well. So here in week 12, what we discussed was this interior barrier function method, right? And what we so this was the discussion, and both penalty terms and penalty parameters. Then solving optimization problems using the interior barrier function method. Next, there were discussions on dynamic programming In this context, the Bellman's optimality principle was also discussed. Some optimization problem, you can solve it using this technique where you can use this Bellman's optimality principle. Next is this multi-objective decision making, or it is called as NODM. And there were discussions on multi-attribute decision making, MADM, you can call it. Then finding Pareto optimal solutions in this context. Pareto optimal frontiers, whatever you call it, or Pareto solutions. So, for example, when you have multiple conflicting objectives, right? Okay, so that was the main discussion. So I think it's almost time. I'll just check how much time I have. I won't go over time for the last one. Okay, so I have some 2 minutes left. So these are the topics that have been covered in this course, and all I can say is that good luck with the exams. Okay. And yeah, you can post your queries in the discussion forum, but whatever has been posted till now, it's actually that's not my job to I think reply, because those are kind of specific and related to assignment. If the options are wrong and those kind of things, if your marks will be increased and so on. So the instructor should take care of it. And related to some concepts and which is specific, I think someone asked about this churns method, and that thing is also not very clear in that video. That's so hope the instructors or the main of the course would come back with some solution. But typically we just make some copies of the columns, and using some min ratio we break ties in churns method. Okay. So, and both the linear and nonlinear optimization parts were vastly covered in this course. And then you learned this constraint and unconstrained optimization, various techniques to learn from simplex to all the way to PKT conditions and so on. So that was mostly about this course, and I think I'll stop with that. I'll stop because, yeah, I have gone over time anyway. Okay, so thank you all for attending few of the sessions or listening to it on YouTube later, and I'll wish you all the best for the exam, and yeah, hope to probably see you in future in probably another course. Yeah, thank you all.